Hello there, we're Team 1. I'm Gregory Yeager.
I am Eric Sarcar.
And I'm Brian Cooke.
We have the privilege of presenting for you today robots and military applications. We decided to choose the military reconnaissance robot. This is used primarily in war zones. A number, as Brian will present here in a second, were used in Iraq and Afghanistan. They're used in hostile environments where we'd like to save human lives as well as deal with the elements. For example, in Iraq and Afghanistan, climate changes existed, whereas humans wouldn't normally go. Robots are able to go. Also, they're very easy to use. Anybody who's ever played a video game can control the great majority of these robots. With that, I'm going to turn it over to Brian, who's going to present to you the major players.
The key company that's involved in surveillance robots is Recon Robotics. They were started in 2006 under DARPA funding. Currently they have 2,000 robots in field with our United States military. Their key product is the Recon Scout. You see it's a all-terrain style surveillance robot. Has the camera mounted up here in front, as you can see. You're also able to throw the robot, as I will show you in the next video. Here you can see in the top left corner the point of view of the surveillance camera itself. And as you saw from that pretty incredible throw, the robot was able to survive the the rise up and function normally. Now I'm going to leave you with Eric, who's going to explain the general trends in this field.
The general trends in size really depend on the application. For example, the Israeli Guardian is a surveillance vehicle that's also meant to intimidate. Therefore, it's a large size compared to the Recon Scout or even the Talon shown here. It's about the size of a dune buggy. And we also have the Talon, which is mostly a bomb disposal vehicle and used in urban areas. And then we have things like the Recon Scout for stealth and for portability. It has a much smaller size. Most successful designs for the arms have been RRR, RRP, and PRP. Future expectations, the sizing. The sizing, like I said, it really depends on the application. But we expect that most surveillance vehicles are going to get smaller and more agile. The increased adaptability is going to be modular, where you're able to have attach more things like manipulators, additional cameras, or maybe even additional weapons with deadly or non-deadly force. And the pricing, as it is, pricing has really gone down. They start off over $100,000 for most models. Eventually, they now, like the Talon, which is pretty much standard, it's about $60,000. And then you have something like the Dragon Runner, which has become more popular, which is a much smaller vehicle, stealthier vehicle, and faster. And that one ranges from $46,000 to up to $87,000, depending on the equipment. Now, here's going to be Brian talking about robot design.
For this presentation, just as we've been presenting earlier with our survey, we decided to stick with a surveillance robot. The two tasks that we wanted our robot to complete would be to look over an obstacle, such as a wall or a car, anything that's obstructing the view, as well as inspect underneath vehicles, such as this CL, UL, which is a device used in the US border to look under vehicles. Alright, the optimal solution for this robot included the use of a 3R robot. This allowed us to move from one smooth movement from the under vehicle inspections to over obstacle inspections. The platform is expected to be able to be mounted on multiple styles of vehicles, remote control vehicles, as well as personnel driven vehicles. Now I'm going to leave you with my teammate Greg, who's going to discuss the workspace parameters.
Hello there. Based off our link lengths of 1.5 meters for A1, 1 meter for A2, and 0.25 meters for A3, we've established a workspace that was an arc with a radius of 2.75 meters. The camera angle we knew we needed to keep between negative 30 degrees for viewing over objects to positive 90 degrees for looking under objects. For our inverse analysis, we found there were two closures for our phi values. One we referred to as the elbow up. The other we referred to as the elbow down. In the elbow up, phi 2 will have a negative value. In the elbow down, phi 2 will have a positive value. Based off of the Jacobian that we calculated, setting determinant equal to 0, we found that anytime that phi 2 was equal to 0 or a multiple of 180 degrees, we would experience singularity positions. With our elbow up closure, you can see following the green line is our phi 1. Following the light blue line is our phi 2, and following the purple line is our phi 3. Our end effector angle is shown with the red line, ranging from negative 30 degrees to positive 90. As you can tell if you follow the path of phi 2, the value never reaches 0. This is good in showing us that as you transition from our first point to our final point, we smoothly transition without passing through a singularity position. With that, I'm going to leave you with Eric to show the animation of our robot.
As you can see, the animation begins at the lowest point. This allows for the arm to be placed underneath a vehicle. As it goes higher, you can see that it follows a straight path, a linear path here, where it had focused on a point around here. At its highest point, it's a little high. It's much higher than a little higher than 6 feet. Now that's higher than most walls or fences. Now the animation showed that we were able to accomplish our goal. We have a smooth transition between the lowest point to the highest point. We also have a generic base for modular mounting on many vehicles that are available. Now, as the prevalence of surveillance robots increases, the price should also decrease, and also we should see a drop in casualties in the military due to surveillance. Now, we have to compare the price of life with the risk that the military personnel runs while they're exploring unknown, maybe hostile areas. Thanks to these robots, we'll be able to do that more efficiently.
Thank you for watching our presentation. We appreciate your time. Actually, pretty much. It's going to be a little less than